So just like how yesterday we did the vertical and linear pair problems, today we're going to deal with the relationships based on parallel lines. So one of the first things I want to do is draw a pair of parallel lines, and then use my notation to make sure we know that they're parallel. And I'm just going to number the angles. 1, 2, 3, 4, 5, 6, 7, and 8. And one of the first things I want to ask from you is, can anyone tell me what one pair of vertical angles are that you see in this picture? Let's start with Chase, then we'll go to, oh goodness, I know it starts with an A. No, it doesn't. Malka. Yeah. Then we'll go to Malka, then we'll go to, Max, and then Robert. Okay, so 1 and 3.
2 and 4.
2 and 4.
5 and 7.
5 and 7.
6 and 8.
And 6 and 8. Okay, so those are all the angles that are across from each other from two parallel lines. Now, what do we know about the measurements of vertical angles? They're the same, or that they're equal, or even that they're congruent. All of those terms are good. So one of the things you want to make note of is that the angles are equal, because this is going to be the piece that we use to set up our equation. So if ever you see vertical angles, we set them equal to one another. Okay, let's go on to the next type. Alternate interior angles. So I need 2 volunteers. Let's try for some new people on this one. Spread the wealth. Michaela.
Yeah. 4 and 6.
Okay, 4 and 6. And what's the other pair? Abby or Abigail? Abby. 3 and 5. Okay, 3 and 5. So what do we know about the relationship of angle 4 and 6, the measurements? They're the same, they're congruent, they're equal. So we want to make note that alternate interior angles are equal, because that's going to be the piece that we use to set up our equations. The next type, alternate exterior angles. So again, let's get 2 more volunteers out there. Let's see, Gustavo, can you tell me one pair of alternate exterior angles that you see? Which pair? Close. Okay, think of the word 1 and 7. So alternate, they have to be on alternate sides. So 1 and 7, thank you. Aliana? Yeah.
2 and 8.
And then 2 and 8 would be the other one. Okay, so what do we know about the measurement relationship between alternate exterior angles? Anyone notice the pattern yet? Angles are equal or congruent. Okay, so again, that's going to be the piece we need to use in order to solve our equations. Okay, the next type that we have, corresponding. So this one I need 4 volunteers, and I'm trying to pick new people. So unless we don't get 4, then I'll come back to people who've already gone. Okay, so 4 more people who can give me a pair of corresponding angles, just one pair. Skyla.
2 and 6.
2 and 6, because they're both to the right of the transversal and above the parallel line. Okay. Maddie.
1 and 5.
1 and 5.
But it can be on each side.
Yep, so these are the corresponding that are on the left and above. 2 and 6 were on the right and above. So we have 2 more. Let's go with Rosemary.
Angle 4 and
Angle 4 and angle 8. And one more, Gideon.
3 and 7.
3 and 7. So what do we know about the measurement relationship between corresponding? They're equal. Okay, so these are 4 of our relationships, but we actually have 2 more. The other 2 that we have are the only ones that are not equal. Okay, so the other pair that we have are consecutive interior. So this one, I need 2 volunteers, people we haven't heard from, as to a pair of consecutive interior angles. Okay. Let's go with Jasmine. Can you pick out one pair of consecutive interior?
4 and 5.
4 and 5. Angle 5. And then Jillian?
3 and 6.
3 and 6. Sorry, is it Jillian?
Oh no, I just go by Jill.
Jill. I didn't write that. I will make note of that, Jill. Okay, so consecutive interior, these are angles that sum to 180. So these are supplementary. So when we so these ones we're going to treat like they're a linear pair and just add them together to equal 180. The last kind that we have are adjacent angles. So do you guys remember the word adjacent? Next to each other. So this one has this one has a lot of adjacent angles. So let's see. Justice, can you give me one pair of adjacent angles?
1 and 2.
1 and 2. Okay. Samantha, can you give me a second pair of adjacent angles?
8 and 7.
8 and 7. Daynuna, can you give me another pair?
5 and 6.
5 and 6. Marcellus.
4 and 3.
4 and 3. All right, I think that's good enough. So again, adjacent angles like 1 and 2, those are a linear pair. So what do they sum up to? 180. Let's see, 8 and 7, same thing. 5 and 6, same thing. 4 and 3. Now the other ones that you have, 2 and 3 are adjacent, so you can add those up to 180. Same with 6 and 7. So this one has a lot of adjacent angles. So one of the things you want to note is that angles sum to 180. That's our key takeaway that we're going to use for adjacent angles. So every problem that you have on this assignment is going to involve you needing to set up an equation, whether it's you're setting two things equal or you're adding them together to 180. So the first question that we should ask ourselves is what angle relationship do we have, so we know which one to do. Okay, so I think I have 3 examples. Yeah, 3 that we're going to go through, and then you'll have time to work on your assignment. So before we move on, are there any questions on just the terms and their property? Okay. Let's see, so our first example, parallel lines cut by a transversal. And I'm going to just say this now. Pictures are never accurate. Okay, so if I might draw a picture like this, but my angle that might look acute might end up being obtuse based on the numbers, because sometimes I just draw the picture and I don't think about what the numbers are. So if you get that, trust your numbers, don't rely on the picture. So here we have parallel lines cut by a transversal. We're told that n is -20 and that p is 21. We're going to find x, y, and z. So on this one, because I don't know any angle measurement, I do know these 2 values. So I'm going to plug them into the expression. So -20 for n plus 2 times p to figure out what this angle is right here. So -20 plus 42, and then add those together and we get 22. So that means this angle right here is 22 degrees. So now what I'm going to look for are the relationships x, y, and z have with that 22. So in looking at this, can anyone tell me a relationship they see? Aliana.
X and that angle that you just did, they're vertical.
These 2 angles, the 22 degree and x, are vertical, which means they're equal. Okay, what's another one we can now see? Rosemary?
X and
X and Z
Z are alternate interiors.
are alternate interior, so we can set those equal. Okay, what about the last one, Robert?
One across from Z is vertical.
The one across from Z is vertical, you're right. Anything else? We got one more letter that we need. So let's see if we can figure out a relationship between y and some of the angles that we know. They're adjacent. So what can we do to find y, knowing that x and y are adjacent angles?
That's 180.
They add up to 180. So 180 minus 22 gives us 158, so y would be 158. So this process that we just went through is what you're going to be doing on the assignment. You're going to be looking for those relationships to try to find all the missing variables. And you can find extra information too. That's fine. It's just about getting that practice. So any questions on this one before we go on to the next example? Okay. Okay, so this next one we are going to do has the same setup, 2 parallel lines cut by a transversal. And here we're just finding x, or solving for x. Okay, so what relationship do you see or can you find between those two angles? Yes, so they're alternate exterior, so that means that we can set them equal to each other. So negative 1/2 x plus 12 will equal 3/4 x minus 8. Okay, how many of you guys like adding and subtracting fractions? Okay, that's usually the response. So, do you guys know how to get rid of the fractions so you don't have to? We multiply. What do we multiply by? We have to go bigger than 2 because we want to consider both denominators. So what you're going to look for is the least common multiple. So the smallest number that you can multiply 2 and 4 to become. So I know Maddie said 8, and 8 would work. Is there a smaller number though? 4. So I'm going to multiply everything, including the 12, including the 8, the 3/4, and the 1/2. So each one of these terms is going to get multiplied by 4 over 1. So when we multiply everything by 4, 4 times negative 1/2, we'll be able to cross cancel and get negative 2x. 4 times 12 is 48. When we multiply 3/4 by 4, the denominator cancels with that 4, leaving us with just the 3 on top and x. And then 8 times 4 is 32. So you have one on your you have 2 on your assignment that have fractions. So this is going to be what you'll want to do if you don't want to simplify or add your fractions together. From here, we can just combine like terms. Whoops. So add 2x, add 32. So we'll get 5x on the right, and we'll get 80 on the left. Divide both sides by 5 to get that x is 16. So number 11, same way. That's the one you were asking about. I believe it's that one. That's the same way. Okay, any questions on number 2?
I'm still confused why did you work that?
Okay, so what I was looking for is I want to be able to cancel out my denominators. Like that's our goal with finding a number to multiply by. So I'm trying to find a number that will reduce with my denominator. So to do that, we look for the least common multiple. So do you guys remember learning about least common multiple? Okay. So to find the least common multiple, if it's one that you can't think of off the top of your head, you can look at the factor trees for each one. So 2 and 4. And you're going to take the highest number of each factor. So see how 2 has a 2 and a 1? Well, this one over here has 2 2's. So I'm going to take the higher amount. So I'm going to take 2 2's, and then I have the 1 times 1. What is 2 squared times 1? 4. That's the number I'm going to multiply by. And if sometimes we're able to see it right away to know that, hey, 2 goes into 4, so if I multiply by 4, it'll reduce it. But ones that might be a little harder, you can always go back to your factor tree and find it that way. And if you go, like Maddie had suggested 8, we could have done 8. We just would have had bigger numbers that we would have had to divide by bigger numbers in the end. So another way to do it is just to multiply the denominators together. So 2 times 4, you'll get a number that reduces them. It just might not be the smallest. Okay, did that answer your question?
Yeah.
All right, so number 3. This one, our directions are going to be a little bit different. 5x plus 35 is this inside angle, and this outside angle is 45 degrees. Okay, so in this one, we don't know that the lines are parallel. You're going to be asked to find the value of x that will make them the lines parallel. Okay, so when we don't know for sure that they're parallel, then we don't know all those relationships. We don't know that alternate interior angles are equal, and we don't know that alternate exterior are equal. Those we only know for sure if we know they're parallel. So when we get one like this that doesn't tell us that they're parallel, but it's asking us to find the value of x that will make it happen, then you want to use the exact same relationship. So to make these parallel, we have to make sure that vertical angles are equal, because then that will make them parallel. So even though the directions are different, we go about solving it the exact same way. Okay, so when you see that change in the in the directions, that's all it's really not going to change how you do it. It's just changing what it means. So when we look at this, we want to again start with what is a relationship that we see between the angles. Do you see a relationship between the angles? Do they match any of those that we've gone over? Okay, as of right now, no, they don't. Okay, but does anyone see something we might be able to do with the 45? Chase?
If you add it to 5x plus 35 and set it equal to 180, you can find x to make it parallel.
True, but how did you know that they sum to 180? Because it doesn't match adjacent or consecutive interior.
You just follow what you said before about they're supplementary.
But how do you know that? But how do we know that? Because it doesn't match either of those relationships. Because consecutive interior, we would have had to known this one, and then adjacent, the 45 would have had to be up here. Rosemary? You're right, they can be, but how do you know that?
There's 45 to be corresponding to the angle adjacent to 5x plus 35.
Okay, so this one, we have to do a little bit of thinking first before we can set that 180. So 45, it's a corresponding angle to this one. So I know that one's also 45, making these two adjacent, so we have a linear pair. You could have also used vertical angles to move the 45 inside here to again get the same relationship. So if you don't see a relationship right away between the angles, use what you know about what you know is equal to rewrite it to find a relationship that you could possibly do. So 45 plus 5x plus 135 equals 180. So 5x plus, why not 135? 35. Plus 80 equals 180. 5x equals 100, so x is equal to 20.